Next, we would be drawing the free body diagram for that same, in the same situation where you have the left section of AY, we'd have a 400 Newton force, which would be AX, right? And AY would be, and just clarify that this is pointing in that direction. This is 400 magnitude, and this would be 96 magnitude, right? And at C, you would have the shear force, normal force, and you'd have some moment right there. If you remember the wall support, when you have a wall support, right, you have the X component of the force, and you have a Fy component of the force, and you also had the resistive moment. So when you actually take a cut along beam, you treat it like you would have a normal a wall section. So when we did with the original diagram looking like this, right, and you take a cut right there, one of the things that we then treat this as is our wall component, and we say, well, this would have to have some resistive moment. We would have to have an X, which we call a normal, and it also has to have a Y component, which we're referring to as the shear, right? And so we have MC, X, and Y component, and that's how we treat this problem, or all of these problems. So applying, looking back again at, let me just move this over a bit. Looking back again, we would have the 400 Newton force going to the left, a 96 Newton force acting downwards, and on this end, and that's A. And when we take the cut at C, we have our normal, we have our shear, sorry, we have our normal, and we have the reactive moment, C, right? So applying the equations of equilibrium, so we say sum Fx would be equal to normal force minus 400, which would equal to 0. So the normal force at C is 400, right? So the X, 0, and that's how we solve that. We sum the forces in the Y, and you'd see that negative VC minus 96 would be equal to 0. So VC would be equal to, and VC has to be going upwards, right? If this is going down, then VC would have to be going up. So remember, it's all relative. If you have a downward force, that force must be equal and opposite to it. And then when you have the sum of the moments about C, you'd have 96, right, times this distance here, which would be, I believe it was 1.5 was the number, right? 96 times 1.5 plus MC is equal to 0. So MC would be equal to negative 144 Newton meters. Yay.